Let's take a look at how to solve the absolute value equation. Absolute value of 2x minus 4 plus 3 equals the absolute value of x plus 5. We can solve this equation algebraically by leveraging the fact that opposite expressions, opposite values inside the absolute value evaluate to the same amount. So we can create four simpler equations that don't have absolute value if I take the positive and negative of this expression and the positive and negative of this expression and pair them together in all possible ways. So let me write out what I mean by that. Now the four simpler equations come from taking 2x minus 4 as it appears in the left side of the original equation and x plus 5 as it appears on the right side. The second equation comes from taking 2x minus 4 and the opposite of x plus 5. And the last two equations, we take the opposite of 2x minus 4, so negative 2x plus 4, and x plus 5, negative 2x plus 4, and negative x minus 5. Notice that plus 3 stays the same in all the equations because that's outside of both absolute values. So what we want to do next is solve each of these equations to find the possible solutions to the original equation. By solving the four simpler equations, we see four possible solutions: x equals 6, x equals negative 4/3, positive 2/3, or 12. However, we don't know which of these four numbers are actual solutions, and so we need to check. One way to do that is with a graph. By treating each side of the equation as an absolute value function, we can create a graph, and the solutions to the equation correspond to the intersection points. And by drawing the graph fairly carefully, we can see that there are two intersection points, one here just to the right of the y-axis, and then one a little further along. It's fairly clear that one of the solutions corresponds to positive 2/3, since it falls between 0 and 2. And the second, it's maybe a little harder to determine whether it corresponds to the positive 6 or to the positive 12. We can determine that by plugging the numbers back into the equation. So for a more precise check, we can always plug numbers back into the original equation. If I plug in 6, I get 11 on the right-hand side and 11 on the left-hand side. So 6 works. Whereas if we plug in 12, I get 17 on the right-hand side and 23 on the left-hand side. So the general algebraic strategy for solving an absolute value equation that has two absolute values is to split it into four simpler equations, solve each of those equations, and then check to see if one or two or none of the solutions are actual solutions to the equation. And we can do that two ways: by looking at a graph or by plugging the values back into the original expression. I hope you enjoyed the video. Thanks for watching.